Okay, we're going to go live now. And wait a second, I'll just get my notes up to make sure I know what I'm saying for housekeeping. Here we go. We're streaming now. Hi everyone, thanks for joining us. It's one of our sessions on climate change and where we are, of course. I'll just do some quick housekeeping before I hand over to Sonia and Paul. Please add any of your questions in the Slido. The link is in the show notes underneath this video on YouTube. And we'll try to get through as many of those questions for you as possible. And also please provide any feedback that you have on these sessions so that we can improve them for future. That is also a link in the show notes too. And so, and if you want to have any comments in the video on YouTube, you can do that on the side, but those questions won't be answered, so keep them into the Slido if you can. And I'll just hand over to Sonia to introduce Paul.
Hello. Yes, welcome to today's sessions about futures from the frontiers of science. We've got Paul Behrens today with us, and he will talk about the latest science on climate change and climate impacts, and as well as some solutions, hopefully. And Paul is an academic and an author in environmental change at Leiden University. He's a physicist by training with a PhD working on wind energy from the University of Auckland in New Zealand. He's worked with industry, NGOs and academia, as well as the Royal Society of New Zealand, providing expert advice to government on environmental sustainability and other issues. His research on food, energy and climate change has appeared in leading scientific journals, and in 2018 he was awarded Leiden University's Discoverer of the Year. In 2020 he published his popular science book, The Best of Times, The Worst of Times, Futures from the Frontiers of Climate Science, which describes humanity's possible futures in paired chapters of pessimism and optimism. His work on science communication has appeared in the New York Times, Scientific American, and on the BBC. So without any further ado, I'm handing over to you, Paul. Welcome.
Thank you very much, Sonia. Thanks a lot for the lovely introduction there. I'm just going to share my screen here and hope that it all goes well. Yeah, so great. So today we're going to talk a little bit about the latest science in terms of the different IPCC reports. We're also going to talk about what the general solutions are, where we should be focusing a lot of our efforts. I think there's a lot of different people talking a lot about different solutions out there, but we can say certain definitive things about what will probably make the most difference. So before I start, I just wanted to give maybe a little overview of why I wrote this book. So this is a popular science book that's based in the science. So it's, I hope, very robustly researched in everything in there is come from the scientific literature. And the reason why I wrote it was because I was reading a lot of books where I was reading some quite negative stories, some quite negative science for about 90% of the book, and the 10% at the end gave this sort of little optimistic ray of hope. And it was really hard to see how that fit together with other problems, with other systemic issues. How do all the systems that we have, energy, food, economic systems, interact with one another, and what are the major approaches? And so one day I put out a whole bunch of books which I'd been reading, and noticed that you can go all the way from the sort of very optimistic views of the future, the very hopeful views of the future, all the way to the sort of very pessimistic views of the future. And I'm not saying anything about whether either are correct, but that there is a space to be had for developing a vision of a hopeful future, but also being honest about the current trajectory and how pessimistic that looks. Okay, so today I'm just going to talk. I see that my book is on the right-hand side here, which suggests that it's really negative, but it is paired chapters of pessimism and hope. So today we're going to talk a little bit about some of this pessimism and hope. Just a reminder of the trajectory for 1.5 degrees. This is from the special report, the IPCC special report. And this trajectory is remarkable. This is a year-on-year declines that we would have to see, equal to the sort of most rapid, actually a little bit faster than the most rapid declines during COVID. There are actually two lines on here. And this is one of the first things that I want to talk about, is some of this uncertainty. This gray line is less steep than this blue line. And so this gray line is different to this blue line because there are different assumptions about the level of overshoot. So when people talk about 1.5 degrees, they're talking about 1.5 degrees by 2100. And often this can mean that we overshoot 1.5, so we go to 1.6, 1.7, and then bring it back using large-scale carbon removal in the second half of the century. Whereas the blue line is minimal, very low overshoot, and so it's much steeper, so we have to get to net zero faster. Note that this doesn't include any sort of differences between different countries around the world, different things about responsibilities, different things about the capacities for different countries to go to zero. So to look at this a bit further, I plotted this animation, and this animation will start again, so don't worry if you miss it. But this basically shows what happens when you delay net zero, as you delay net zero. What happens to the required carbon removals during the second half of the century. The orange line is currently where the policies are going, and this black line is the resulting, what we would need to see net zero by certain years. Now, there's a couple of things to bear in mind here, is that the longer that we delay it, the more negative emissions we need. And these negative emissions are somewhat of a modeling artifact in integrated assessment models to ease the gradient of what we need to do in terms of reducing the emissions. And because these negative emission technologies are so untested, and because some of them have such downsides, we need to be extremely careful about using them, relying on them. So for example, if we were to delay net zero by 2070 worldwide, then we would be looking at bioenergy carbon capture and sequestration, which is the largest land use of type of negative emissions, about twice the size of the EU. So we would need an area twice the size of the EU drawing down carbon every single year. That does get a little bit better if you're talking about direct air capture, then you're talking about twice the size of Ireland. But you were talking about national or continental scale carbon dioxide removal by 2100, the longer that we delay here. Even if we delay just a little bit by 2050, we're talking large scale carbon removal. The other aspect I want to point out here is that this is actually for a 67% chance of 1.5 degrees. So this is not even, a 90% chance. And this really leads me on to my next point, which is that there's an awful lot of uncertainty around these carbon budgets. These carbon budgets really range quite wildly. There was a really good study that came out 2 years ago that integrated a whole bunch of different ways of looking at the carbon budgets and tried to produce a probability curve for how much budget was left for 1.5 degrees. And you can see that the probability here is at its highest here. That's around 440 gigatons of CO2. But we can see that there's a non-negligible chance that the budget is negative here, which would mean that we've already gone over the budget. There's some level of zero emissions commitment. There's some level that ongoing processes will take us over 1.5 degrees. But on the other side, there's also some non-negligible amount that actually the budget is going to be larger than that. So there's a huge amount of uncertainty for any specific temperature target. And as you might imagine, as we go to 1.6, 1.7, 1.8, then the remaining budget is just going to move further and further to the right here, and quite a bit by 2 degrees. But there's a lot of uncertainty here. So we're looking at a situation where we could have already blown it, and if we wanted to be 90% sure, then actually we would have to be 0 this year and start drawing down. Or we've actually got more than we thought. So that's something that we really have to sort of keep in mind when we're communicating about these temperature targets. The other thing that I want to just talk about is, aside from these temperature targets, we as scientists, and I think policymakers, we focus on the colors, on the scientific figures, the different blues and the reds. We talk about numbers, but too little do we actually show the pictures of what climate impacts are already doing today. And I think we need to be doing this more, not to necessarily scare people, although it is really, really scary, but just to highlight the human cost behind this, because we often talk in abstractions about carbon budgets, about temperatures, and we need to start talking, I think, a lot more about people's individual experiences. So this is something that I'm trying to bring in more. I mean, when you see some of these when you see some of the news events, maybe recently, things like Partygate, for example, if I think about political things, this really took off with visual examples, people could connect with it more. And I think we need to start doing that a lot more in the presentations that we give, and potentially to policymakers across the board. Even if it's a technical presentation, always worthwhile, telling a story from somebody who's experienced some of these changes. Okay, so, just to further emphasize this uncertainty between, in both the development of the planet and also society. Some of you already might be well aware of this concept of tipping points. We don't have time to go into the different sort of types of tipping points today, but there are tipping points beyond which are irreversible in the climate system in any reasonable time for humanity. And a paper came out a few years ago that suggested that these tipping points may actually be coupled together. So at the lower end, at the lower warming, you could actually get situations where this could tip further tipping points as we go, domino effects. It's really, really important to emphasize that scientists have done a really good job at the average temperatures and estimating the average temperatures on the planet, but the large-scale tipping points have been sort of largely systemically underappreciated, or under sort of modeled. They are very, very difficult to model, or underestimated is the word I'm looking for. We also see tipping points in society. We see all sorts of activism. I think one area that I'm very interested in following is the tipping points in climate litigation. And this is even from a few years ago now, but we can already see a rapid increase in the amount of litigation against companies, against governments from climate groups. And one of the most important things about this is that a lot of these tipping points in society have feedback effects. And a really clear feedback effect in the legal system is this process called discovery. So if you take ExxonMobil to court, then they have to reveal data and reveal reports. And those reports can be lower they'll lower the barrier to entry for other groups to bring more legal cases against other companies. So it's like a feedback effect where each effort lowers the threshold for another group to make an impact, for another area of society to have an impact. We, of course, see some tipping points in financial systems. There's an awful lot of talk about green bonds, and there's a lot of talk about changing the ways in which banks may be leveraged in terms of the amount of risk to an exposure to CO2. We need to see sort of far more change there, but once that does start to come in a real way, that will really change the underlying structural flows of the economy. And just to sort of emphasize that, we don't need 100% of people to adopt a certain behavior or to believe in a certain thing. Actually, what the science shows is that often you have a tipping point in society where a committed minority can shift the majority view in a tipping point process. So if, for example, in this figure here, you can see that, between 20 to sort of 30% of a committed minority can flip the majority view. Okay, so one area that we have more certainty is this area of sea level rise. We know that sea levels will continue to rise for hundreds of years. But we can see that even here, there's a fair bit of uncertainty from AR6. This is the most recent Working Group 1 report on the natural and physical basis of climate change. And if you look at this report, you'll see that each of the recent reports, the numbers have increased each time for the amount of expected sea level rise. So AR5, the previous one, the special report on the cryosphere was suggested even higher levels. AR6 sees even higher levels, and now they've started to introduce these low likelihood, high impact storylines, these high impact events that could actually really dramatically increase the severity of these tipping points. And we should remember that actually in AR5, they'd already increased some of the sea level rise levels by about 60% compared to the previous report. So it does sort of illustrate, over and over again, and as Stefan Ramsdorff makes a good point about this, that the IPCC has been too cautious in the past, which is not great for risk. And it has had to correct upwards again and again and again for these impacts. So given these impacts, here we go. So given these impacts, I think the lesson is brace ourselves. If you don't already know about it, this is a fantastic website from Carbon Brief, the sort of online reporting of climate sort of legislation and impacts around the world. It's a fantastic website where you can go and you can click on any of these icons and you can look at the scientific study that directly attributes an extreme event to climate change. So all of these have got scientific studies connected to them that say either it's been 3 times more likely, or it couldn't have happened without climate change, or that climate change has impacted in different ways, and even the ones that, you know, they couldn't draw a connection. But these are all attribution studies where they're running a model with and without climate change and looking at the exacerbation of those events. I often say to people, you know, look up, you know, where you're from, and to students, you know, go to where you're from, where you're interested in, go to where you travel, to have a look at how climate change is already, but from scientific literature, being shown to impact the weather events there. Okay, coming back to this point about large-scale discontinuities, these things that I'm talking about in terms of the sea level rise, ice loss, these sorts of things, you know, these impacts that we thought that would be happening about 5 degrees C in sort of the early 2000s, we now think could happen and unfold, you know, almost between 1.5 and 2 degrees. So that's how far down and how close to the risk that we've gotten. And we're starting to see this really play out in real time. We saw a lot of sort of shock at the scale of the floods in Germany. There are a whole slew of papers showing that the climate signal on crop yields in agriculture is actually coming out much earlier than people thought. And some of that is very worrying, especially if you get multiple places being impacted at the same time. And even just recently, we saw a completely unprecedented, 7 sigma events. So way, way, way out of anything that we could have possibly thought could happen in terms of heat waves in the Arctic and the Antarctic. So this is really a question of brace ourselves, because I think there has been, as I say, a very good estimation of the average temperatures for the concentrations of greenhouse gases in the atmosphere, but a sort of broad underestimation of the sort of natural impacts of what could unfold due to the redistribution of the energy in the climate system. I wouldn't normally show a figure like this because there's a lot going on, but one of the reasons why I put it in is because there's a lot going on. This is a paper that came out a few years back that looked at all of the different ways in which society could be impacted by climate change. It found something like 427 different pathways about how climate can interact in causing all of these issues in infrastructure, health, water, food security, economy. And, you know, we recently had the Working Group 2 report for the IPCC, and I hope many of you have read it, at least the summary for policymakers. And, you know, they're saying a similar thing as to the natural sciences, in the sense that action is more urgent than previously assessed, that human societies are less resilient than previously thought, that projected risks are higher, and that there has been this underestimation. We need to get onto it, especially on this adaptation. They mentioned that beyond 2040, and depending on the level of the climate changes, there are numerous risks to natural and human systems. In the Working Group 2 report, they identified 127 key risks and assessed medium and long-term impacts that are multiple times higher than currently observed. So, you know, this is heady stuff, and we need to get to this situation where we're realizing that this is a wolf at the door type situation. And it is late in the day, but when I think about the hope that we have for the future, it's remarkable how much we already have and how much that combines to make a much better world for all of us. So if I think about the energy transition, I'll talk about each of these a little bit more in a moment, but if we talk about the energy transition, mostly renewables, insulation, changes in urban form. When I talk about the food transition, we're talking about the great food transformation, which is a change in diets, a reduction in waste, and a change in production. And we talk about an economic transition. So an economic transition that's away from a growth model. Doesn't necessarily have to be degrowth. It can just be an ignoring of growth and a focus on well-being and what makes societies thrive. Notice that I'm not talking about population for here. This is something that comes up quite a lot. So I just thought to add this slide in now. Not talking about population here, mostly because population isn't really the right question to be asking. It's much more a question about consumption. And when we have a look at population anyway, the situation is changing very rapidly. So if we have a look at this figure here, we can see that everywhere is the fertility rates are dropping much faster than they did in the West. It took about 85 years for the UK to do what Rwanda, for example, has done in 5 years in terms of dropping its population in fertility rates. And this is mostly driven by women's autonomy and women's freedom. And so when we're talking about population, if you're concerned about it, then you really have to be a massive feminist first, and then the population comes as a nice extra, really. And when we have a look at any single analysis of population and the impact it plays, this is called a decomposition analysis. So you decompose the different drivers of climate change. And we can see that this is a log plot. So the population is an order of magnitude lower in importance than wealth increases. So trying to make space for those wealth increases is far more important than any sort of conversations around population. And of course, when we look at the world in general, far more emissions come from the higher income. So this is one estimate. These numbers are a bit squishy, but roughly the richest 10% are responsible for about half of all emissions. So the world can cope with many, many more vegetarians than they can with carnivores. So we've got to think about it in these terms. So feminism is the priority, and population is just a nice additional extra. One thing I should mention that is quite remarkable is most of the areas. A lot of the areas in Europe, in America, China, other areas in Southeast Asia, Japan, obviously, they're all shrinking quite rapidly. China's shrinking very rapidly. It posted 1.3 babies per woman last year. I mean, you're losing 700 million people by 2100. I mean, it's remarkable. And this could map quite nicely, I guess, with climate impacts. So you could see climate migrations in terms of balancing out the populations around the world, the remaining demographic growth that you might see in regions that are going to see higher climate impacts, for example, in Africa. Okay, so anyway, moving on to the energy transition. So the energy transition, the story is really quite simple. I mean, we like to make these things complicated, and from a policy level, of course, they are complicated. But from a where to focus and what to focus on situation, it's really quite simple. So we electrify almost everything with mostly wind and solar by a very, very large amount. They're just very cheap. I'll talk about that in a moment. And we can already electrify about 70% of energy demand cheaply. If we have a look at this study in Science a few years back, they found that the remaining areas that are quite difficult to decarbonize, your aviation, your shipping, long distance transport, some seasonal storage for electricity, and some industrial processes. So deep decarbonization is harder, these little pies that sort of come out here, these pie pieces that come out here. But if we start now, it will become easier, and some technologies are already coming on very quickly and surprisingly quickly. So how fast can it go? I mean, if we're talking about the rate of change that we need things to move very, very quickly. The battle is pretty much already over. Renewables win. And the reason is because these renewables look much more like a device, like an iPhone, rather than big spinning turbines. And each time that you do something, you get an opportunity to learn how to do it better, to increase efficiencies, to use fewer materials, to use fewer inputs, to use better supply chains, easier installation processes. And this is all combined to have ridiculous learning rates. So for every doubling within the solar industry, depending on whether you measure at the cell level or the installation level, you're looking at a reduction of about 30% in costs, which is remarkable. So that's just come down really, really fast. And it's getting to the point now where in a lot of regions, it is cheaper to buy new solar panels, land, and pay people to install it and pay the interconnection than to continue to use existing fossil fuel generation. So if we have a look here, it really depends on where you are, whether you've got cheap gas or cheap coal. Some places have cheap gas, some places have cheap coal, some have neither. So Germany, for example, even Germany, with poor old Germany, with like some of the worst renewable resources in the world, and papers show this out. I mean, Germany is always going to have to pay a lot for its energy. Even Germany, renewables are cheaper than the coal and gas there at the moment. So, and by 2040, this will be the case worldwide. So the issue is not really technology. I mean, there is indeed technological issues for decarbonization, deep decarbonization, sorry. So for some of those sectors, there is an issue. But for the large majority of the energy use of society, it's not really an issue. The issues are really things like transmission. Transmission reduces the overall costs of the switch a lot. And energy markets, you know, our current energy markets are set up around a sort of dispatchability, marginal dispatch curves, but we don't need to go into it. But basically, we need a revolution in the energy markets to allow this to happen, and that includes demand side management. So for hard to decarbonize, it's really the commercialization of some of the existing technologies and the rapid rollout of them. And, you know, the hydrogen economy perhaps, but I think there's some debates about how much of an impact that will really make to the large amount of energy that we're using in that 70% easy to decarbonize, electrify area. And if I look at the food transition, so that was the energy transition, but if I look at the food transition, even if we decarbonize the entire energy system, the current food system is enough to push us over 1.5 degrees. I mean, you saw that very, very rapid decline. So really, there's such a small gap left that even the food system on its own can push it over. And that was a very interesting paper from Clark last year, I think, or 2 years ago. If you look at any study on this, any large-scale study, that looks at the total food system, they find the same three things every time. They find dietary changes needed, they find food waste, it needs to be reduced a lot, and we need production changes. Here I've got the one from the World Resources Institute. These are the agricultural emissions for a 2050 baseline. So that's where we would go if we had no changes from the current system. And this is the target where we need to get to. And so if I plot how far of a difference plant-rich diets can make, it's by far the largest of all the different opportunities. Then there's food waste, which is also a very large opportunity. And then there's technologies. And then there's other. I mean, this includes things like, long-term growth rates, population growth rates, consumption, other consumption factors. So you can see that the largest impact is plant-rich diets here. That's not to say that there won't be any ruminants left. There certainly will, but it will just be far, far lower than it currently is today. In some very, very specific cases, there may be room for ruminants, but in general, it's very difficult to make things work with the large-scale use of livestock. And the land spared, of course, can be saved for biodiversity protection or renewable energy. We recently wrote a paper or published a paper on this, looking at what would happen if high-income nations went towards plant-based diets and that you were to save the land upstream. About 80% of all agricultural land is used for livestock, and that land is a huge opportunity cost, either in terms of the carbon sequestration that could be harnessed there by letting it revegetate, or by biodiversity protection. And of course, that land sparing can also include, other sort of ruminants, but in a more wild setting rather than in the kind of settings that we have for dairy and meat producers today. We find that you actually save an area the size of the EU if all high-income nations go towards a plant-based diet. I mean, in the UK, for example, you save almost an area the size of Scotland. It's not quite the size of Scotland, but it's getting there. I mean, it's a huge amount of land. So going as fast as we can if we're serious. I mean, if we're actually serious about this 1.5 degrees, people still say they're keeping the 1.5 degree target alive. But, if you're actually going to get really serious about this, a large proportion of the productive capacity of society now has to be harnessed, because it's always about rate of change. It's all very well to roll out heat pumps over a decade or 2 decades, had we started a while ago. Now we have, we should be doing it in 5 years or less. Now you're talking about a labor force that's completely different to the labor force you would have needed for 10 or 20 years. So really we have to start these large-scale programs as soon as possible. And if we're really serious about this does mean bringing huge amounts of people into the labor market in the areas that we need to change. And this is what I think scientists talk about when they talk about a warlike mobilization, which is it's a bit sketchy because climate change can be a threat multiplier, of course, and it can drive war. But this is what's meant. So this does mean a greater role for governments, carbon taxes, very strictly regulated markets. Governments even steps in and operates where there's clear market failures that just are not working. I mean, sometimes I think, the installation schemes, I mean, they're just still, way behind where they need to be. A lot of them were stopped. And even when they were expanding, they weren't going fast enough. So maybe there's just more scope for government to step in directly and do this. Of course, no matter what happens now, we've got a very rocky next few decades ahead of us. So we're not going to get to net zero tomorrow, and it's going to take some time still. And in that time, the concentrations of greenhouse gases are going to go up still. And so we do need this adaptation planning at a very local level, from the local councils all the way up. And there's obviously related political dangers everywhere to this. So it does require sort of laser sharp leadership and good democratic inputs. A clear example of that is things like citizens' assemblies. So when we when we think about this, sort of keeping everybody on board through this, we really need to sort of think about the media and what the media's role is in this. As humans, we're quite often apt to shift our baselines. And so this means that we get used to the more degraded environment. This was something that was found in fisheries research, where even experts would underestimate how much fish there should be there, because each generation of experts saw less at the start of their careers in terms of the diversity and numbers of fish. And so even fishery scientists you'd expect would really know have this shift in baseline. This is a study that came from that analyzed tweets, and they looked at the number of years exposure to a 3-degree anomaly. And to begin with, there was quite a lot of tweets saying, oh goodness, this is hot. But after a while, after about sort of 5 to 8 years, it started to drop off. And then that became not normal, more and more normal over time. So people got used to the 3 degrees anomaly and thought, oh, well, that's actually just quite normal. I don't know about you guys, but the last couple of months have been kind of shocking to me, because I certainly remember when it wasn't this hot. And when we look at sort of the terms that are used in the media and the focus on climate change, the terms dog and cake were used far more than climate change in UK TV. I mean, I know cake is great, but it's kind of important to be talking about climate change. There has been a bit of a turnaround about this. Some of the footage from COP26 was quite encouraging. But one thing I want to sort of really drive home here is that there will be a roughly annual cycle in places like the UK, in the Northern Hemisphere, where a lot of people live. This annual cycle, things will get scary around summer, around autumn. Things will happen. We'll get heat waves. We will get flooding. We have to be prepared for this when this happens year on year on year on year. I'm certainly somebody who doesn't really look forward to summer anymore. So, to harness this change, to really have this feeling that, we actually really need to move faster on this. We need to sort of harness this idea of this punctuated equilibrium. When these things happen, we have to use them as opportunities to try and adapt to future harm and to reduce the level of future harm by harnessing them as opportunities in order to reduce future impacts. So keeping everybody on board, I mentioned the Citizens' Assembly. And of course, when you actually look at it, people are far beyond where the politicians are talking about. So the Citizens' Assembly, for example, about 108 people around the UK from all sorts of walks of life. And they're coming up with, they get sort of told about climate change. And they're coming up with solutions like frequent flyer taxes, getting rid of SUVs completely. I mean, these are far beyond where the politics is currently at. So there's also a level of sort of, using these to trust in people and move a bit faster. If we think about just transitions, then we have to look after the people who are going to be shifting. I've talked about a dietary shift. There's a massive change then in production systems. People who have invested millions into milking facilities, for example. You really need to find ways to look after them and redirect the subsidies, the huge amount of subsidies. I mean, arguably food is easier because the money is actually already there to a large extent. We just need to do sort of redirect these subsidies. When I think about these rapid transitions, I think, when I think about the technologies, I think the faster investments pour in, the faster the costs come down because you scale. You get to these tipping points where the incumbents become cheaper, new technologies become cheaper than the incumbents, and the faster, better technologies outcompete. And this is a feedback. And we will see this in other areas that we choose to invest in. So be they electrolyzers, heat pumps, we will see some technologies have more scope for reducing in costs than others. But we will see this for anything that's on these sort of unit scale that we can do in its millions rather than, one-offs like a large nuclear power station, for example. And not necessarily against nuclear, by the way. It's just ridiculously expensive, and it just doesn't seem to be that it's going to be online in time. And in society and behavior, you see the same processes. So the faster that we make smaller steps, so the leaders go vegan, or the leaders go vegetarian, or even just cut down meat to a very small amount, the further steps become easier because the market responds, restaurants give more opportunities, and research shows that more people will try vegetarian meals if there's lots of exciting opportunities. So one thing in The Hague, for example, is that they ask restaurants to have several vegetarian options on their menus. And that drives even more change because it allows even more people access to explore new dessert, dishes and things like this. And so the faster change becomes. So you get this tipping point again with these feedbacks. So with these biggest things, these biggest things that we're talking about in sort of the individual actions, it's mostly transport, diets, insulation. And I often say, sort of, don't be purist, take some small steps. They really help in taking the next step and then reevaluate. And do talk about it. We do lots of stuff with the students where we do assignments where they have to talk to people about climate change because it is so difficult and uncomfortable. And we have to get used to talking to people about their hopes and their fears. Catherine Hayhoe has a great book about this. And that's how we get the systems change as well, because we have this social contagion. Systems and individuals are connected. It's not one or the other, it's both of them at the same time. So one of the things I sort of say at this unique time, be honest, alarm people, do alarm people. I think it is really alarming. You'd be inhuman if you weren't alarmed. Give solutions, act. And by acting, you're building that hope, So we're moving through that process of being shocked, that process of maybe feeling like, oh my goodness, this is too much. It's never going to happen. It's too late, this sort of thinking. And we're moving towards this, oh, well, if I feel this strongly, and ultimately it's worthwhile doing absolutely everything I possibly can. And by doing absolutely everything I possibly can, build some hope for the future. And the IPCC puts this very well. Every action matters, every bit of warning matters, every year matters, every choice matters. And also knowing that every single one of those things are going to improve the world generally anyway. So we're talking about Ukraine at the moment. Ukraine, we're going to see energy and food impacts and market impacts. Both of those are improved by energy and food transition. So let's just do the things that we know we need to do anyway, that we know we should have started to have done a long time ago, and we'll address a lot of these other issues too. So there's a lot more in the book. I'm sorry, I kind of slightly went over there, but there's a lot to talk about, and especially in some of the recent reports.
Oh no, thanks, Paul. That's great. Yeah, we know it's a massively expensive issue.
Stop sharing.
Yeah, I'll just do some quick announcements.
So much, Paul. Oh, that was fascinating. Ian, were you trying to say something?
Yeah, there we go. I didn't unmute myself. They'll have heard me on YouTube. Anyway, it doesn't matter. Yeah, no, thanks very much, Paul. I was just going to go through some quick announcements, let some people get some questions in as well. But just in light of what Paul's just said, if you check out our pages on what you can do about climate change, we've just updated them. So there's some really good stuff in there, from the best bank to go with to resources that you can find on all the streaming networks, including YouTube as well, because we know that climate's fallen off the agenda in schools now because of COVID restrictions effectively blocking up their educational attainment at the moment. So do check that out. And also we've got a page on diet aptly for this. It's based on the National Food Strategy, and there's some great material in there, and obviously links to recipes for dietary change. But do have a look at that as well. And just have a look around at our YouTube channel. Paul's on here as well in his Climate Gen CC interviews that he did. There's some really amazing stuff out there, and not just about the learning about climate, but also climate solutions. And we've tried to link to as much of that as we can on our YouTube channel. And also try and join the Slack community as well, and just let us know what you're up to. The community, the platform will get the information to people who are interested in it, just through the preferences that they've selected. But and if you don't know how to use it, then we can show you how to do that. I'll stop talking now and hand back over to Sonia for some questions. Sonia.
Thanks, Ian. So I'll start asking the questions we have on Slido, and hopefully we can get through all of them. So first we've got Martin, who's asking how serious an impediment to the necessary growth in renewable power generation is the global supply of rare earth minerals such as neodymium? I can't pronounce this.
Neodymium.
For wind turbines.
It's a serious issue that we have to think about going forwards. It's not something that is going to be in the way now. It's something that we need to plan for. We're moving from a situation where economies are basically flows. So we take in petrol, we take in gas, we burn it, and then it dissipates, and there's just a flow. It's like a river, that's coming in, and then we're dissipating its carbon dioxide in the atmosphere and polluting everything, to a situation where we're moving to stocks. So renewables, for example, they have metals and materials in them, wind turbines and solar panels and batteries, and these sorts of stocks of materials in society. And so we're moving to a situation where we can actually start to think about how do you keep those materials within society. So once you've built up those stocks, as long as you design for recovery and recycling and reuse and all the things we talk about when we talk about circular economy, we're going to be okay. That does mean, though, that there are material issues in terms of getting to that level of stocks in society, and for everybody to get to that level of stock. But there are ways to reduce the stock that we need through things like public transport, greater efficiencies in homes. We don't need to overbuild things, through better electric car infrastructure, for example. We don't need, you don't necessarily need 110 kilowatt hour batteries, if you've got fast charging. So it's all these sorts of things coming together to sort of alleviate this. And we do have to start thinking about that now. For the short term, I don't think, if we do think about that now, I don't think that it's as much of an issue as people say it is. I think it's more of, say, maybe a geopolitical issue. It's not necessarily about whether the resources are totally there. It's more sort of that geopolitics about the reshaping of the energy system, which will be messy.
Thank you. And next we've got Matt, who's asking, 200 years ago, natural carbon cycle, emissions and absorption were in equilibrium. Are natural emissions accounted for in climate models, or just fossil fuels?
Yeah, natural emissions are accounted for. Yeah, totally. Natural emissions and sequestration as well. So the land sink is also included. The ocean sink is also included. Yeah, I mean, you name it. All of it is in the climate models. Now, there's arguments about, how well they're represented in the climate models. So, for example, clouds, we have a hard time with. We have a hard time with some non-linear processes that we can't, model at a very fine scale. So, one of the reasons why we've seen a faster disintegration of ice sheets is because of pooling of water on the top of the ice sheets, and also the grounding of where the ice sheet sits on top of the land. A lot of that was very difficult to parameterize in the models. I mean, they were there, but we didn't realize how quickly they could happen. So it's more a question, anything you could ask is in a climate model. It's more a question of how it's parameterized and where are still the unknowns.
Thank you. Next, we've got Lily, who's asking, how important is the role of the imagination and storytelling, such as portraying climate change in movies, books, songs, and plays, to create social change?
Yeah, I think that's really, really important. And I do think that's one of the reasons why climate change is really hard. I am not going to say that communicators are doing a bad job. I think climate change is just a really, really hard one to communicate in clear stories and narratives. It's either something that is too apt to be simplified and you miss the bigger picture, or it's something that's just too vast. It's too difficult to make into a story. It's a struggle for people, I mean, even with, I thought Don't Look Up did a great job. But even in Don't Look Up, there are some things about it that just don't map very well to climate. So it's this slow encroachment, it's this inevitable change of a very large system that is hard for people to grasp. And the interconnected human systems by which can be affected by this. We were already struggling with resilience before. We run a very tight ship in societies, I think. There's a great emphasis on efficiencies, on optimization, on price. And who's paying for the resiliency? It's not really there. I mean, we have insurance, of course, but now the world is moving towards an uninsurable state. So all of our systems have adapted in the Holocene, and the Holocene no longer exists for us. And so what does that mean for all of our systems? And I think that's probably a case-by-case basis in terms of storytelling. I do think the pictures, I think, we do have to have these pictures in our presentations. I've been as guilty as that as anybody else. After that picture, I just went on to a whole bunch of different solutions and graphs and sciencey things. And that's because I'm a scientist. But, we can tell stories about this as well, and tell stories about how individuals are also changing their world for the better. In terms of they're putting solar panels up, they've insulated their houses. I think that's some of the most powerful stuff. Some people who've really enjoyed new meals, new dietary shifts, these sorts of things, the excitement of change, as well as the sort of that feeling of sacrifice or abstinence. It doesn't need to be that way, I'm
just going to dip in quickly, Paul. There's one thing, Saul Griffiths, I don't know if you've heard of him, but the energy analyst, yeah, he was I saw him being interviewed in the Atlantic the other week, and he was saying that if we carried on at the rate we're going with renewables, everything will be electrified by 2037. And obviously that's like eye-wateringly quick compared to what I think a lot of people would think we're capable of doing. But does that sound realistic to you when you talk about the supply chain issues and just the scaling up of skills and just implementing and plumbing in these technologies?
Yeah, it's a good question. The issue now is not necessarily the technologies. You could get there in 30, yeah, you could get by 2037, no problems. I mean, in the book, even just the back of the envelope calculation, given how much we've scaled already, you could get to 100% sort of renewables, or close to 100%. You know, maybe you've got some nuclear, maybe you've got some other things. You could get there within 15 years, given the current trends. Easily 12 to 15, even 12. I think I was looking at the other day. The question is the social aspect of this. Do we have markets that allow that to actually happen? Or do we say, no, we can't have any more renewables on the grid because we can't find value for them. We can't do the load shifting that we need to do. We're going into energy policy here, but the issue is all the planning for transmission lines across the country. It's these sorts of issues that are far more likely to hold up this transition than the technological questions.
Just segue into a really quick one as well. I've heard before that several times now that renewables will do themselves out of a market because they'll be so cheap that they won't be able to be competitive in some way and make money. Is there any kind of credence to that?
That's only with the current market. We've set the market up in such a way that that would be the result. But we can set up a market however we like. We can set up a market. What's the value of renewables? The value of renewables is constantly going to be improving over time if we can build markets around it so that we can pay people for demand shifting. So, they shift the time at which they use for using vehicle to grid for their batteries for their cars. If you get paid for these shifts, or even if they're regulatory based, people say you need to keep your car, even if we're slightly more sort of paternalistic about this, it's totally fine. So this is called this value deflation, that the next bit of solar on the grid will be generating at the same time as the other solar and bring down the value for all of it. Well, that's only true if we don't value the other things that come along with it. And already a lot of the solar farms in the US, for example, are being built larger with storage so that they can shift when they sell the energy. So they've got batteries on site so they can shift and pay into the grid and get the money. So it's really about what we value, how we set up the market, rather than any sort of ultimate truth about renewables being sort of deflationary in value.
Thanks.
I don't know, did that make sense?
No, it did. Yeah, it did. I was just waiting for Sonia to come back in with other questions, so I'm just hogging all the airtime.
Thank you. Yeah, that was fascinating. We do have more questions. So we've got Matt again. He's come back asking, so how does restoring habitat create offset headroom for more fossil fuels?
Right. No, great question. So it's sort of, this is where things get a little bit local and a little bit complicated because different habitats are very different across the whole country, across the whole world. And there are different levels of carbon that's in the trees, that's in the vegetation, which are in the animals, and which is underground in the below ground matter in the soil carbon. So it really depends where you're looking at. But many of the lands around the UK and around the world are currently storing much less carbon than they could. Because once you allow more energy to flow through nature, it's able to harness more of that complexity, that carbon that's coming into the system, and the level of carbon which you can store in that habitat is generally higher than what we had before. So I hope that answers your question. But the level at which the difference is at really depends, really wildly around the world.
Yeah, that makes sense. Thank you.
Oh, and of course, this is just another perfect example of how doing that fixes so many other things. Like water pollution from too many nitrates in the water, air pollution. In the US, for example, animal agriculture again is the largest contributor to air pollution from agriculture. We're talking sort of all sorts of different impact, biodiversity loss. It addresses so many things.
Yes. Thank you. I think we could have an event on itself on all of that, but to to be fair, because we've got still plenty of more questions.
Okay, yeah.
Through them. So we've got Henry who's asking, how confident are you that decision makers will make the big changes needed? For example, you mentioned heat pump installation. What do you think will swing the balance?
I think people, I think the last few years of activism and people out on the streets and the response to the Citizens' Assembly and all of these sorts of things just show that people are desperate for this change, and we don't need 100% of people. So it's a little bit controversial. There's been some pushback, but Erica Chenoweth, her work on changes in society, she found that tipping points in society, if you get about 3.5% of people on the streets regularly, then you can actually flip the system. It's a little bit like there's tipping points in nature. You can flip the system, you can flip the change. This has been critiqued there and back about whether it's violence or non-violent actions and things like this. But the point is that you need many fewer people than people imagine in order to make this change.
It is interesting because now we do have this, it seems we're in a different world now where people are much more willing to protest about things as well. Like direct action in the 90s felt like it was a reasonably rarefied thing. And now it's like there's so many easy ways for people to start making that step. As you said, if you start small, then you can quite easily become do things in a more impactful way. And obviously we've got social media where we can just like things and put a Ukrainian flag on our profiles and stuff. But all of these things help us to feel like we can take action and we have some agency.
Yeah, it's that agency thing, and it's the networks as well. So, this is another example of network effects and how that can turn into tipping points, because networks scale much faster, between humans, because we all know 3 or 4, the 6 degrees of Kevin Bacon or whatever it is, so we all know other people and it spreads through society like that. So, yeah, usually it feeds off itself.
And that's the thinking behind groups such as XR and such as, so we're already kind of seeing it put into action. Yeah, it's interesting. So we've got Martin next, who's asking, do you agree that governments should switch subsidies from fossil fuel exploration to household energy self-sufficiency, such as solar panels, thermal and rechargeable batteries?
I mean, absolutely. Absolutely. I mean, nobody's saying that this is going to be smooth. This is going to be rocky. And it is true that but it's going to be rocky in any case. It's going to be rocky from climate impacts, or it's going to be rocky from rolling out these policies, which may not hit everybody perfectly. They may not have to be the right targeted section of society that you need to target. These sorts of things. There's going to be mistakes that are going to be made, and so this is what I mean by keeping people on board. So that people understand these mistakes. They ask things to be, improved in terms of that. But I don't want to just give a simple answer, like, of course, we need to switch fossil fuels to renewables. So I'd much rather say that, it probably will be a messy rollout. We need to try and get ahead of that and think ahead of that as much as possible and make sure that, the really important things in life, keeping warm, is not gonna, you're not going to lose the important energy services. The energy security is still there, but do it as fast as possible. An example I think about, and again, sort of people laugh at me a little bit, but if Germany really felt, this existential threat from Ukraine, and Olaf Scholz the other day was saying, a lot of suffering if we cut this off. Well, there's some simple things. You take every healthy person below a certain age in Germany, and you say, well, turn your heating down 5 degrees. We'll give you some thermals or whatever. I mean, you start to think of options that aren't, they may seem crazy, but they're less crazy than the alternative. And Olaf Scholz going to say, in the meantime, whilst you're wearing those thermals and stuff, we'll get on with putting heat pumps in everywhere and getting on with the energy transition, which we'll aim to do in 3 years, because we're going to be, do you know what I mean? Things become possible when you have things like people invading one another on your doorstep, So, this is the sort of thinking that we need to, I think, think about more.
It's reframing the issue, isn't it? And a lot of the time we're so encumbered with present day thinking. The idea of turning the heating down in your house just seems like, why would you even bother? For a lot of people, they just worry about it and watch the news a lot.
And to be clear, lots of gas is used in other sectors of society too. But there you've already hit the largest energy use in houses, is the heating in Germany. So you've got the largest gas use in consumers. So and obviously the industries have to do their part as well. But yeah.
Yeah. And of course, we've already got some examples of countries that are, like Indonesia is phasing down its fossil fuels. Of course, it's climate-wise very different to many European countries, but we have some examples from around the world where things are being done. So yeah, I think we're reaching the end of our time space, but can we squeeze in one more question? Because then we would have gone through all of our questions, which would have been amazing.
Sure, yeah.
We've got Vanessa who's asking, how can we make evidence about the future as powerful as evidence about the past? Reactive decisions seem to get more traction than proactive ones.
That's a really good question. I think it's more, maybe a better answer is to be prepared when things happen, to harness the moment. So we saw, this sort of, after Ukraine, we've seen this sort of battle in the media between we still need LNG coming from America compared to rolling out heat pumps and electrification. So maybe it's less of a question about always being able to do that vision, but just have something ready off the shelf to go to fight some of the misinformation out there and some of the non-ideal outcomes, like using LNG rather than sort of heat pumps. I mean, I think Bill McKibben had a piece the other day, which was great. He said, do a new Marshall Plan, which is basically heat pumps for Europe. We just convert entire industrial facilities to produce heat pumps and send them over to Europe. I mean, already you're cutting a huge percentage of the gas use in Europe. So I don't know what it would be continent-wide, but I would have thought it'd be at least a third, if not even more. So yeah, I see the problem that you got there, but I think also you want to keep linking it to those events. I mean, we've already forgotten the European heat waves of the early 2000s, where tens of thousands of people have died. I mean, in a way, that's kind of good in the sense that we've adapted, and that with the subsequent heat waves, we've not seen as many people die, so that's good. But we've kind of already forgotten that level of suffering. So maybe also just keep promoting the voices of the people who experience that as well would be something useful to do.
That kind of neatly brings us to the end of the session, Paul. Thanks very much. It's really interesting to hear your perspectives on all of this. And I know that, as I say, I'd really urge people to go and listen to the interviews that you've done with Climate Gen CC on it's on our YouTube channel as well, with Nick Breeze. Certainly the things about population, which is something that I'd really worried about in the past, or I'd thought about and wondered how we were going to deal with that. You talk about some of the situations where we can help others, and also it can help us as well, and finding solutions to these problems within the problem themselves. So I'd really urge people to go and listen to that too. And also just to say thanks for doing this. I really appreciate your time. And I haven't read your book, but I'm very urged to read it now after having listened to your podcast. So much detail. But yeah. Thanks very much for that, and also thanks, Sonia, for helping out as well. It makes a massive difference having someone else on hand to help out with questions as well. So yeah, thanks everyone for attending, and we'll see you again soon.
Thanks, Ian, and thanks for all the great questions. Thanks, Sonia.
Thank you.
Okay, we've ended the stream now, so.